Okay guys, let's talk about how to perform the imine mechanism. This mechanism is generally found in the chapters involving aldehydes and ketones. It involves a primary amine, which is either an NH3 group or an amine attached to just one R group. And then that reacts with the carbonyl of an aldehyde or ketone under acidic conditions. Now, the easiest way I have found to learn this mechanism is knowing what you're allowed to start with, what you're allowed to work with, and have a general idea of what your finished product is supposed to look like. Let's walk through the mechanism and then do an example. So with this mechanism, we're allowed to start with a ketone or aldehyde, which is why I've got that highlighted. You're allowed to work with a primary amine. So here we're going to use an N attached to just one R group. You could also use NH3 here. And mildly acidic conditions just means if you need a proton in the name of balancing out charges, it's there. And of course, for every acid, you'll also have a conjugate base, which again is probably going to be here in the name of balancing charges out at some point in the mechanism, because you need everything to be neutral and stable and happy by the time you're through. So first thing we're going to do is we're going to have a nucleophilic attack by the lone pair on nitrogen at the carbonyl. That's going to resonate this double bond up on top of the oxygen to become a third lone pair. And so now I've created two charges, right? So the name of the game here is just get everything back to neutral. So we're going to protonate this top oxygen with a proton off of our acid. And so HA just represents some acid, okay? So if an acid loses a proton, A with a lone pair represents the conjugate base of that acid, just for reference, okay? So now we've taken care of this charge here and formed this alcohol. And then we're gonna take the conjugate base of whatever our acid is and deprotonate this hydrogen located off of our amine group. And it's gonna take us to this nice, convenient neutral halfway point circled here in this orange box. This molecule in itself is called a carbonylamine. Every once in a while you'll see that as a test question. And you're halfway through, which is nice because you get to this halfway point and you know you're almost there. So at this point, notice in the final product, I've got no OH or no water molecule whatsoever. And since we know OH to be a bad leaving group, we can protonate it and make it a good leaving group. So that's what's going to happen in this next step. And then this lone pair on nitrogen is going to resonate down or up, depending on how you want to look at it. And then when it forms this fifth bond here, somebody's got to go. So water is going to act as a leaving group here. And so this is often what's called hydrolysis in your textbook. So then you're going to get to this molecule here. Name of the game, balance out charges, can't leave anything with a charge on it. So our conjugate base of whatever our acidic conditions was is going to come along, deprotonate this, and take us to this nice endpoint that of course we call an imine. So this is the mechanism. Let's try an example where we kind of work everything out step by step. So let's start with this ketone on top of a cyclopentane. And we're going to use nitrogen with an ethyl group as our primary amine. So the first thing that happens is this lone pair of nitrogen is going to attack the carbonyl. That's going to resonate up. So now I've got this molecule here. O with 3 lone pairs, which of course is going to give this thing a -1 formal charge. And then we are now attached to our nitrogen with an ethyl group in both protons. No lone pairs. This is going to be a +1 formal charge here. We are going to grab a proton from our acidic conditions to create this alcohol. And that's going to take us here. HO. And we still have a charge on our nitrogen, which we're going to try to get rid of here in this next step. And we're just going to abbreviate this -H+ to indicate that we are losing a proton off of that nitrogen in the name of balancing out charges. And then we get to our convenient halfway point that we call carbonylamine. HO, nitrogen, which is attached to the ethyl group, and just one hydrogen now. Lone pair creates neutral. Let's box it up, let us know we're halfway through. Now remember, going back to this step, here, our final answer should look something like this. A double bound nitrogen, certainly with no presence of OH or water. So we're going to focus on getting rid of it. And since we know OH to be a bad leaving group, we are going to protonate it and turn it into a good leaving group by making it water. So let's grab a proton here. And then we get to this molecule here. Single lone pair, and that's going to be good enough for a +1 formal charge. And we still have our nitrogen here. And we're going to take this lone pair on nitrogen. It's going to form a double bond here. That's going to kick off water. So here's a hydrolysis step. And now we get to this point here. Double bound nitrogen, still attached to one proton. Forgot our ethyl group. And that's going to have a +1 formal charge on top of nitrogen here. And we're going to lose this proton to create a neutral molecule in the next step. So I'm just going to abbreviate that -H+, like that. And our final answer, cyclopentane with a double bound nitrogen, still attached to an ethyl group, and lone pair, final answer. You will need to know this mechanism for most Orgo 2 tests, but in the event that this mechanism becomes part of a more detailed synthesis problem, there is a little bit of a shortcut if you're not asked to show the mechanism. And again, so you know you're probably starting with an aldehyde or ketone. This is your final answer. And so it's always going to be a double bound nitrogen and then whatever's attached to it, so long as it's neutral, right? So here we go from an NH to R just down to an NR. And so this was kind of all that lasted here. And that also kind of applied here. So you've got your ketone here, so I could kind of look at that and be like, I know I'm probably going to lose these 2 protons in the process. So my shortcut, I could just do something like that. And that is indeed what we have here. If you found this video helpful but need more in-depth explanation and see a lot more practice problems worked out, you can find the full-length version over at orgogoat.com. Please like, comment, and subscribe to help our videos find more students like you. Tell a friend. And if you're interested in private tutoring, or if you want a concept explained that you don't see on our YouTube page, shoot me an email, orgogoat@yahoo.com.